Okay, so in this video we're going to introduce trigonometric substitution. First, we need to be reminded of a little theorem that you might remember from your high school days called the Pythagorean Theorem, where we have sides of a right triangle, A, B, and C, where we have a squared plus b squared equals c squared. Okay? So, say you have a triangle, and what we're going to add to this is some angle theta here. And we know that this side is x and this side is a. How do we write this third side here in terms of a and x? Well, we use the Pythagorean Theorem. All right, so the Pythagorean Theorem says what? A squared plus b squared equals c squared, where c squared is the square of the hypotenuse, right? So we don't know what this is, so I'll just call this y. But that's y squared plus x squared equals a squared. And we're trying to get y by itself, so I'm going to subtract x squared from both sides. And then to get rid of the square, I take the square root. And so I square root. So that y there, we're looking at the positive, okay? So the positive square root, not the negative, since we're talking about distance. So that side can be defined as a squared minus x squared, where a is some number and x is some variable. So if I see a scenario like this where I have like 9 minus x squared, okay, my substitution for this triangle is sine of theta. Now remember, sine of theta, sine is opposite divided by hypotenuse, so this is equal to x over a. That's my substitution there. All right. So for another triangle, we have the scenario, instead of not knowing this lower leg here, maybe it is scenario here where we have theta and we know a and we know x and we want to know what the hypotenuse is. So this would be, say, an application of the Pythagorean theorem. A squared plus x squared equals y squared. To get y by itself, I square root both sides. So this here is the square root of a squared plus x squared. Okay? The substitution here would be the tangent of theta. Now tangent is opposite over adjacent, so x over a for this scenario here. And then the last scenario, we have a triangle. Let's try that again. So got a right triangle. All these are right triangles. Remember, right triangle trigonometry only works with right triangles, right? So, say we know that this side is A and this is X and we want to know what this side is. Well, this would be the scenario where we have some y there. So y squared plus a squared equals x squared. Subtract a squared from both sides. This would be the situation. Once I take the square root, I'm going to get the square root of x squared minus a squared. So how's that different than this first one? Well, the first one had a number squared minus the variable squared. This one has the variable squared minus the number squared. So this would be a scenario slightly different, but very similar to that first one. This substitution would be the secant substitution, secant theta. So secant is the reciprocal of cosine, and so reciprocal cosine, so that would be x over a. All right? Now, if you like this technique, great. To me, it seems like it's confusing to students. So what I like to use, I call the triangle dictionary. Okay, so the triangle dictionary is what I use whenever I do trigonometric substitution, because sometimes it's a little hard for students to remember all these different scenarios. So if it's like, if I've got the 9 minus x squared, what do? I use that sine theta thing going on there. If I've got the square root of 9 plus x squared, I use the tangent scenario. And this one here, if I've got like x squared minus 9, I use that secant scenario. If you want to do that, great. That's perfectly fine. The way I work through this is a little more intuitive. I use the triangle you draw as your dictionary for determining how to substitute. All right, so what do I mean by that? Let's take a problem. So I'm going to do the integral square root 4 minus x squared dx. Okay, so when I think about Pythagorean theorem, okay, how can I write this side as a side on a triangle? So first thing I do is I draw my triangle. Okay, so the first thing that I'm going to do is I'm going to draw a triangle. I'm going to put angle theta here. Okay, I always like to put my angle in the bottom left side here. And I'm thinking, okay, I want a side that has a square root of 4 minus x squared. Okay, when I think about the Pythagorean theorem, all right, I'm thinking a squared plus b squared equals c squared. Now, if I'm trying to solve for the hypotenuse piece here, then I know that all I got to do is just take the square root, and I've got this plus inside here. But that's not what I'm doing here. I've got a minus inside here. Now, say I was going to solve for one of the legs, which is what I am doing here. I've subtracted the b squared from both sides. Now I have a squared equals c squared minus b squared. If I want to get the leg by itself, I take the square root, and I've got the scenario that I want. Square root of something minus something else. Something minus something else. Now, what do I know about square roots? Since we're dealing with real variables, real calculus, what we are talking about with square roots are real components. What do I know about square roots of negative numbers? That's imaginary. So the only way this is real is if this is bigger than this, right? The positive needs to be bigger than what I'm subtracting away, okay? Now the biggest one is always that hypotenuse there. So I know just from looking only at the integrand right here, just looking at that, woo, right? Okay, I know that this is the hypotenuse without doing any math because it's the positive one under the square root. And I know that this one has to be a leg, okay? But what else do I know? Look, in here, this is c squared. So that's 4. So if 4 is c squared, what is c? We'll have to take the square root of that inside piece. So c is really 2, okay? So that's a triangle with a side 2, hypotenuse. And then the b squared, well, the b squared is x squared. Well, if I have b squared equal to x squared, how do I get b by itself? I square root. Square root of x squared is absolute value of x, but we're dealing with real. This is x for b, okay? And so I'm going to label this side x. Now, if you wanted to, you could have chosen this to be your x, and that would be just fine. The only difference you'd be dealing with, instead of cosines, you'd be dealing with sines or vice versa, right? So I just choose the opposite. I like dealing with sine just fine. So this is my triangle. Let's see if it works. I don't know what this is, but if I use Pythagorean Theorem, something squared something squared plus x squared equals 2 squared, right? So I have something squared, and then I minus x squared from both sides, and that equals 2 squared minus x squared. But how do I get rid of the square part? I square root both sides, so this gets me 4 minus x squared in my square root, which is exactly what I want, okay? So what do I label the something? I label it exactly what I wanted, the 4 minus x squared, okay? So let me get rid of all that. Yes. Okay. So this is my dictionary, all right? This is what I'm talking about when I talk about my trig dictionary here, okay? So my trig dictionary, what I'm going to refer to from now on, all right, for any information that I need. Okay. So let's start making our substitutions. Let's use trig to make our substitutions. So how can I get rid of this square root thing here? Well, I can use trig, okay? What trig relates me to the square root 4 minus x squared? Well, if I do the cosine, maybe we need to do a review of trig real quick, okay? So let's think back to pre-cal. So I have this silly little thing, some old hippie caught another hippie tripping on acid, right? So some old hippie caught another tripping on acid, right? So S-O-H, some old hippie. This tells me sine is equal to opposite over hypotenuse, okay? Caught another hippie. What's that tell me? That's cosine equals A over H, adjacent over hypotenuse. Last one, T, tripping on acid. What's that? Tangent equals opposite over adjacent, okay? So this is how I always remember. Some old hippie caught another hippie tripping on acid. That's how I remember what's what. For my right triangle trigonometry, I know it's goofy, but I'm telling you, sometimes goofy is the best way to remember things, okay? So we've got those three things. What trig can I use with respect to this angle here? I want to involve this. I want to avoid that because I don't see an x elsewhere in there. So I'm thinking like maybe these two sides. What two sides is that? Well, that's the adjacent side, okay? And then the hypotenuse side. So I'm dealing with cosine. So cosine of the angle theta is equal to square root 4 minus x squared over 2. Okay? Now I don't have square root 4 minus x squared over 2. All I have is this 4 minus x squared square rooted, right? So I'm going to multiply by 2 on both sides, and that's going to cancel. And so now I get that this square root of 4 minus x squared is equal to 2 cosine theta. So I'm going to substitute. Replace that with 2 cosine theta dx. Okay, am I done? Not really, right? I'm not finished yet. What do I need to do? I need to get rid of this dx because everything needs to be in terms of theta. Well, how do I get a d theta instead of a dx? Well, I need to figure out a way to write x in terms of theta. Well, what relates theta and x? Well, theta is opposite, right? And then I'm going to use this because that's pretty simple. Okay, so trigonometry here says the sine of theta is equal to x over 2. Okay, x over 2. So that right there, my friends, is what helps us out. And what I want you to realize, if you go back up here to your little trick here, what did we say? We said sine of theta was x over a, where a squared is what goes in there. Remember, it was 4 minus x squared, right? Well, what is this? What is, if a squared equals 4, then a is going to be 2. So we're getting the same thing, except we're using a picture instead of just memorizing some random substitutions. So to me, this is more intuitive for students and easier for them to understand. Okay? So why make life any harder than it has to be? 2 sine theta equals x. Now, how do I get dx? I take the differential. Dx equals, take the derivative of 2 sine theta. That's 2 cosine theta d theta. So now this gets replaced with this right here. Okay, so this becomes integral 2 cosine theta times 2 cosine theta d theta. Okay, so this becomes 4, 2 times 2 is 4, cosine squared theta d theta. Oh my goodness. Now we got ourselves another situation here. What's going on? Well, cosine squared is an even power. So I can't strip off a cosine. And if I convert it using Pythagorean identities, I get 1 minus sine squared, so that didn't really help. But what I can use with an even power is a reduction identity, and this is where it comes in handy. 1 plus, since it's cosine, 2 theta over 2 d theta. Okay? Now the 2 and the 4 cancel. It's going to make it a little bit easier on us. Gets us 2 integral 1 plus cosine 2 theta d theta. And from here, I can integrate, not too bad. Integral of 1 is theta. So I'm going to get 2 theta if I distribute the 2 in, right? And then I have plus 2 integral cosine 2 theta d theta. Now I'm rewriting this out. You know, we might be to the point where we can just do this in our head, but I do want to, show as many steps as I can. This is a u substitution. Oh. So u equals 2 theta. So du is going to be 2 d theta, but I don't have a 2 d theta, I just have d theta, so I'm going to divide by 2 on both sides. So I pick up a 1/2 factor. Well, guess what? That's going to cancel with that 2 factor. So really this is just going to be my integral cosine u du. Okay? You see how this d theta here gets replaced with 1/2 d theta, but the 1/2 cancels with this 2 out in front. Really, you got like 2 times 1/2, but those cancel each other. Right, they just cancel out. All right, so the integral of cosine is sine. So this is sine of u plus c, okay, 2 theta. Now, is this my final answer? 2 theta plus sine u plus c? I don't think so. Original problem started in terms of x, so we're going to finish in terms of x. What does u equal? U is 2 theta. So this is 2 theta plus sine 2 theta plus c. Okay. Now, if I stop here, you might be tempted to use the dictionary to help you convert back. But there's a problem. My dictionary is coded to work for an angle theta. Okay? My dictionary is coded to work for an angle theta, not 2 theta. Okay? So can't just willy-nilly flip this around, right? Now, how do I fix this? Well, I know an identity, sine 2 theta is actually equal to 2 sine theta cosine theta plus c. All right, so there's a reason I picked this problem so that you would see it is important that your argument matches the dictionary right here, right? If you're using a Spanish dictionary, it's going to be a little bit different than the English dictionary, right? So make sure your dictionaries line up with what they're supposed to be. So what's the dictionary say? Okay, for sine of theta, the sine of theta, remember sine, some old hippie, opposite over hypotenuse, that's x over 2. So I'm going to replace this with x over 2. Okay, what's cosine theta say from the dictionary? Dictionary says adjacent over hypotenuse, so that's square root x or 4 minus x squared over 2. So I'm going to put in square root 4 minus x squared over 2 plus c. And then 2 theta. Well, you might be thinking, how in the world, Mr. Clark, am I going to get 2 theta? Well, just pick the easy one. I think that this is probably the most simple out of all the trig ones. If I did tangent theta, oh goodness, that'd be x over square root 4 minus x squared. And oh my gosh, that would be just so terrible, wouldn't it? Okay, so instead of going that way, let's go with the easy peasy one. That looks like the simplest one. How do I solve the equation sine theta equal 2 x over 2 for theta? Well, there's an inverse function for sine, and it's called arc sine. So I'm going to do the sine inverse of sine theta, and if I do it on one side, I got to do it on the other side. Okay? And so when I do this, I get theta equals arc sine x over 2. So arc sine x over 2 is the same thing as sine inverse. Okay, so that inverse just means it's an inverse function. All right, so either one of those I'll accept. For your homework, they might tell you write out arc sine. Okay, so you just do whatever the instructions in the problem tells you to do. So the answer 2, sine inverse x over 2. Okay, so kind of a weird solution, but this is kind of a difficult problem. All right, let's try another one. See if our dictionary skills are getting any better. Okay, so example, integral 1 over x squared square root x squared plus 1. Oh my goodness, let me try that again. X squared plus 1 dx. Okay, so let's set up a triangle. First thing I do is I set up my triangle. I'll put my theta in the bottom corner here. And now I'm thinking, can you believe that I can think at all, right? Oh no, this guy's crazy. Okay, so I see a square root. Anytime I see a square root and something plus something or something minus something, I'm automatically thinking trigonometric substitution. That's my go-to, how I know to pick this technique. So since I'm jumping straight to this technique, what I want you to do is think about what scenario has something squared plus something squared square rooted. What side of the triangle is that? So if you need to go back and think about it, that's cool. A squared plus b squared equals c squared. Always go back to that. Think about which one am I taking the square root of, and it's a plus in between. And I think you'll find that the only one that works for is the hypotenuse. So I know right off the bat that this is going to be my hypotenuse here, okay? Because it's a plus in between. So if there's a plus in between both of them, that means this is a leg and this is a leg, okay? So if a squared equals x squared, then a equals x, right? And if b squared equals 1 squared, remember 1 squared is 1, right? Then b equals 1, okay? So that means that one of the legs is 1 and one of the legs is x. So which one you pick to be which is up to you. I just do it like this, whatever. Doesn't matter. Either way is going to get you the same answer. It's just you're You might have lots of sines and cosines in your answer, whereas someone else might have tangents and secants or cotangents, reciprocals, things like that. Okay? So maybe you've got, secants and tangents as one of your answers, and somebody else has cosecants and cotangents in the other. Ends up kind of being reciprocal like in that fashion. Just because your answer doesn't match the back of the book doesn't mean it's not the correct answer. There are multiple answers. That's why it's difficult to grade, but I guarantee I can do it. All right, so we got that scenario figured out. Now all we've got to do is use our trig dictionary and figure out how to substitute. Okay, so what do I have? Well, I have 1 over x squared I need to get rid of. Okay. I don't see an x squared, but I do see an x. Okay, and I see a 1. So what trig function can I use to relate those together? Well, tangent theta is equal to x over 1. So 1 over x would be cotangent theta. Okay? And if I want 1 over x squared, I just square everything. And so if I square everything, then I'm going to get 1 over x squared equals cotangent squared theta. So I'm going to replace this first piece here with cotangent squared theta. So let's do that. Okay. So this becomes cotangent squared theta. All right. And then I need to get rid of this other part here, 1 over square root of x squared plus 1. So do you see anywhere I can do a 1 over square root of x squared plus 1? Yeah, I think so. 1 over square root of x squared plus, that's cosine. That's cosine theta, okay? Cosine theta. And then I have my dx. My dx. How do I get rid of my dx? It's the same always. I'm going to need to do my substitution. So I need to figure out something where I have x equals something in terms of theta. Okay? So what is my something in terms of theta? Well, trig says the tangent of theta is x over 1, right? So I have tangent theta is my something function. So dx is going to be the derivative of tangent theta d theta, which is secant squared theta d theta. Okay? So I'm going to replace my dx with secant squared theta d theta. All right? Now, when I see a whole lot of trig all together, what I think is convert everything to sines and cosines and then simplify. Because if you do that, you're going to make life way better for yourself. Simplify first. So this is what? Cotangent is cosine theta squared over sine squared theta. Okay, and then this is times cosine theta over 1. And then secant is 1 over cosine. So this is cosine squared in the denominator. And then I have my d theta. Guess what? Cosine squareds cancel. So what do I have? I have cosine theta over sine squared theta d theta. Okay? Not too bad. Once you get to this point, you've converted everything to where it's pretty slick. U substitution will get our answer. Now, one thing that I want to point out is that there's several ways to skin a cat. Now, what does this crazy kook mean by this? So say I have 1 over x squared square root x squared plus 1. So let's take a commercial break right here, all right? So put your pencils down. Just watch this part right here. I want to show you what would go on if we did this slightly different. Because really, this is more about figuring out what technique is comfortable for you and then figuring out what works best. So when I see, there are other ways to substitute. I see I have an x squared down in there, okay? So maybe I just want to say, I want to get rid of it. I want to find how to substitute out that x squared. Well, what do I know? Well, I know that tangent theta is x, right? I know that. So that means that tangent squared theta is x squared. So what I can do is I can replace that x squared with tangent squared theta right there in the denominator, okay? Now you might be saying, well, that's not what we got earlier. What did we get earlier? We got cotangent squared. But remember, the reciprocal of 1 over tangent squared, okay? That's a reciprocal identity that says that that's equal to cotangent squared. So it is actually the same thing, all right? So kind of cool. And then same thing with this one. If I'm just looking to get that by itself, I could use the secant instead of cosine. So secant theta is just the square root x squared plus 1. So I replace this with secant theta right there. And then my dx, same thing here. It's still this same right there. So that's where the secant squared theta d theta comes into play. Okay, and then once again, we convert everything to sines and cosines. And so it might be easier if we simplify this first. So make this so sine squared theta over cosine squared theta times 1 over cosine theta. And then this is 1 over cosine squared theta d theta, right? And all this stuff is going to flip, change, flip, keep the numerator the same, change from division to multiplication, and flip the denominator. So on the top I get cosine cubed theta over sine squared theta, and I multiply by that 1 over cosine squared theta there. Okay, and now I can simplify. The cosine squareds cancel, and I'm just left with 1 cosine theta up top and 2 sine squares in the denominator. And guess what, people? That's exactly what I have there. So I'm just trying to show you that you don't have to say, oh, I got to find something where it's exactly like this. You could have just said, look, I can find this, and then stick it in the denominator, kind of like we did there. Okay? So all that to say, commercial over. Let's start the problem right back. Pick it up again right here. And if I do that, I'm going to do a u substitution. U equals sine theta. Then du is equal to cosine theta d theta. Why did I do that? Because I see the derivative of itself right there. And so I'm going to replace sine with u. And so I get u squared in the denominator and du here. Holy smokes, that looks pretty easy, right? So this is the integral of u to the negative 2. Exponent rules, right? Always convert, so you're not doing something silly. Add 1 to the exponent, negative 1, divide by it, plus c. And what is u? So recall that this negative 1 here doesn't mean inverse, okay? It doesn't mean that it's the inverse, it's the reciprocal, okay? So be careful with that. So we flip it over. So this becomes negative 1 over sine theta plus c. Well, what do we know that 1 over sine theta, that's equal to cosecant theta by reciprocal identity. And now all we have to do is convert back into theta to x, use our triangle. What's the triangle say to do? Triangle says sine is opposite over hypotenuse, so we're going to do hypotenuse over opposite. X squared plus 1 over x plus c. And that, my friends, is the answer.